what we're going to be doing today is looking at the connection between the graphs of sinusoidal functions and the equations of sinusoidal functions if there have been vertical stretches, horizontal stretches, vertical translations, horizontal translations. The whole A, B, H, and K thing, although you will notice that something is amiss here. Something looks a little bit different in terms of those parameters, and we'll get to that. So in this lesson, we're going to be applying all of the transformations that we have previously learned about. We're going to apply them to the graphs of the functions y equals sine of x and y equals cos of x, and to the equations, because you can't transform a graph without transforming the equation. So if we take this template and we apply it to sine of x, this sine of x is f of x. And what a f of b bracket x minus h n bracket plus k means is a times f of b bracket x minus h. So we're going to put b bracket x minus h in for x, and then you add the k afterwards. Right? We've talked about this numerous times, that if f of x was not, say, sine x, but if f of x was x squared, then it would be in brackets b times x minus h squared. And the same thing can be said for cos of x. So this is what we're looking at today. However, instead of using h, we use c when it comes to trigonometric functions. And instead of using k, we use d. Why is that? Well, one of the reasons is probably because we use k for the period when we're talking about trigonometric functions. It shouldn't matter, though, and students never struggle with this. All it means is that these are the transformed functions. If I go back and look at this thing, if you keep your eyes peeled on the h's and the k's, they're just c's and d's, that's all. Okay. Quick review of what we know happens. The amplitude is going to be the absolute value of a. There's no need, everybody, I mentioned this yesterday, but I'm going to mention it again. There's no need to think of vertical stretches here and go, well, what's the new amplitude going to be? It's a memory game. Whatever the parameter a is, that leads you to the amplitude. The period, of course, is 2 pi over b, and absolute value of b. I just reviewed that before we started this lesson. And again, if you want to work in degrees, it's 360 degrees over b, absolute value of b. So when it comes to h, which is now c, we would normally say that there's a translation, a horizontal translation, left or right, by an amount of the absolute value of h units. And if h is negative, it goes to the left, and if h is positive, it goes to the right. This is just the equivalent statement, but changing all the h's in what I just said to c's. So c is the parameter that tells you about the horizontal translation. There is a slight change in something, though, and it's that we call it something specific in terms of trig functions. We don't just say it's a horizontal shift or a horizontal translation. What we call it is a phase shift. And you need to get used to seeing that phrase or hearing that phrase, phase shift. There is another issue. So I want to take a little detour here. If I would have told you prior to today that you have, it doesn't matter, y equals f of x, and then you have a new function which is g of x equals f of x plus, I don't know, 6. That should be child's play for you to understand that g of x will be the result of taking f of x and translating it 6 units to the left, correct? Okay. So what we would say is the translation what we would say is the translation is 6 units left, right? And I've impressed on you that it's wrong to say the translation is negative 6 units. Just because, first of all, it's sloppy. You're not telling me whether you know it's left or right or up or down. You're just saying, oh, it's -6 units. And secondly, because it's just not what we do in this context. But if I gave you y equals sine of x, and then y equals sine of x plus 6, we can say here the phase shift is -6. We're allowed to. Because I guess the thinking is phase shift, that phrase that has phase in it, is telling you it's left or right. That's what a phase shift is, when you take that whole wave and you shift it left or right. By definition, that's what it is. So only in trigonometric functions can you get away with saying that the horizontal translation is a negative number. But you don't say horizontal translation, you say phase shift. The phase shift would be -6. Or the phase shift would be 6 to the left. Either one is acceptable here. So you might encounter that. There's a vertical shift or translation by d units. Can you just help me out with my note construction here? Do I have absolute values around the d in your notes? It should be. There should be absolute values there. And that's a vertical parameter. That used to be k, now it's d. It's down if d is negative and up if d is positive. And there's one more little thing here. We have a special name for that. It's called the vertical displacement. Rather than saying vertical displacement, we say it's the vertical, or rather than saying vertical translation, we say it's the vertical displacement. And the order is the same as the order that we talked about before with A, B, H, and K. You have to take care of the effects of A and B before you tackle the effects of H and K. So you have to do A and B before C and D. So let's get going here. We're going to use our knowledge of transformations to sketch the graphs of a couple of functions. And then we're going to talk about the domain, range, amplitude, and period. But just, I want you to hold off on drawing anything for a second, because we can make this complicated or easy. And if I show you what's happening and maybe a bit of a complicated explanation to begin with to get to an easy destination, then you will know how to do it easier all the time. Somebody at the door? Maybe? Can you check, Jeff? I didn't hear it, but I saw a couple people look over there. So you're not writing anything down just yet. We know that the parameter of A, you can write this down. A is -3/5. And K happens to be 1. Would everybody be in agreement on that? Well, see, I wrote K. D happens to be 1. Are we in agreement on that? Okay. So the amplitude is 3/5. So the amplitude is 3/5, no question about it. And what we would have done yesterday is for the range, we would have put -3/5 is less than or equal to y, which is less than or equal to +3/5. But there's been a translation here. So now put your pencils down again. Don't write anything down yet until I tell you again. I know that we have to take care of the amplitude first. We have to take care of the vertical stretch first. So what ends up happening when we do that is that the middle of the graph will be, I just want to change this a bit, that the middle of the graph before any other changes is going to be there, correct? And the top of the graph, if there were no other changes and it was just cos x, would be there, and the bottom would be here, right? Okay. But that 3/5 creates a new amplitude of 3/5 with that same vertical midline. That's actually a horizontal line, but it's measuring things vertically. And then, forget about what we're going to draw. We would draw that, but then it gets shifted up 1 unit. But what that means is that the middle of the graph is going to be at 1. If I take these three horizontal lines, and if you like, I'll change the color of the middle line. If I take those three horizontal lines and I translate them, because they're enclosing the graph, I translate them up one, the result is the following. The middle of the graph is going to be at 1, and it's going to have an amplitude of 3/5. So what we're doing is we're saying these are the boundaries of whatever we draw. And if it hasn't dawned on you, these three things are all connected to each other. Whatever D is, no matter if there's a stretch horizontally, or if there's a stretch vertically, or if there's a translation up or down, whatever D is, that will be where the middle of your graph is going to be. And your maximum will be the amplitude above it, and your minimum will be the amplitude below it. So by looking at A and D only, and it's why I made this example simple, by looking only at A and D, you know where your guidelines or grid lines or boundaries are, and you can go ahead and draw those. And now we can imagine that it's still at the bottom, centered around the origin where we know it's not. This is a cosine graph, right? Where does cosine start? And don't say at 1. It doesn't start at 1. And don't say at 3/5. Where does a cosine graph always start? At the top. So what you do is you go to the top and you put a point. And now we're going to say to ourselves, but A is negative. So what will that do to our whole plan of starting at the top and going down? Well, this would be what would be happening if A were positive, but that means since A is negative, we have to start at the bottom going up. Are you with me on this? Okay, what's the period? The period is 2 pi. Why is the period 2 pi? Because B has a value of 1. C has a value of 0, so we don't have to worry about moving things left or right. All we have to do is draw, starting at this point here. I'll put it in green so you can distinguish it. This is the correct point. Draw an up, up, down, down in a cycle of 2 pi radians. So it's going to end in the middle here. Notice, whoops, it's going to end at the bottom there. Notice I'm talking about where it starts and where it ends without even looking at the y-coordinate. Like, I honestly have to think now about what the y-coordinate is. I think the first point has a y-coordinate of 2/5, doesn't it? Looking at the graph. And then it goes up, up, and it ends up at what I want to say is 8/5, 1 3/5, and then it goes down, down. Anyway, we can graph this now by splitting this into 4 equal chunks. And that will be kind of our set of guidelines or boundaries or cues, I don't know what you want to call it, that tells us it has to end up going up to here, down to here, and then down to there. And it would continue on, and if it were a written response, you'd put arrows on there and maybe draw another cycle. The domain is any real number, of course. And the range, if we look at this, it goes from 2/5 to 8/5. It should not be lost on you that 2/5 is D minus the amplitude, and 8/5 is D plus the amplitude. Because D is where the middle of this thing is, and you add the amplitude to D to get the maximum, and you take the amplitude away from D to get the minimum. You cannot you cannot put lowercase a here. You cannot say it's the parameter d minus the parameter a. This would be wrong unless you did this. Because if a is negative, which it is, it wouldn't work. You'd be taking away a negative to get the minimum, which would mean you'd be adding a positive. Very quick, maybe type of exam question, where I give you the following. I say that the range of the following function, y equals a cos b bracket x minus c n bracket plus d. I don't even tell you what those things are. And the range, let's just pause for a second because this is crucial. The range is determined solely by a and d. Because a is what stretches the thing to give us a new amplitude to begin with, and d is what shifts that whole thing up and down. B, doing this to the graph, doesn't affect the range, and neither does c, doing that to the graph, affect the range. If I tell you the range is -2 is less than or equal to y, which is less than or equal to 20, you ought to be able to figure out what a and d are. The thinking here is that to go from -2 up to +20 is 22, isn't it? Whether you take 20 minus -2 to get 22, whether you reason out it's 22, well, that's two amplitudes, isn't it? The middle of the graph has to be here. That's two amplitudes. So if I also give you the condition that a is greater than 0, and I say, what are the values of a and d, you know that a is 11. You can figure that out. In fact, this first part is like the example we had yesterday where I gave you the coordinates of the 2 points and you had to find the amplitude. What is the value of d? Well, what we could do, there's lots of things you could do. You could take 20 and subtract the amplitude. 20 minus 11 is 9. You could take -2 and add the amplitude. -2 plus 11 is 9. You could, and this is what your textbook teaches, take the maximum and the minimum and add them together and divide by 2 to get the average of them, which is the middle. If I take 20 plus -2, I get 18. Divided by 2, I get 9. The range is all wrapped up in the values of a and d. Okay? Which leads us nicely to this example. If we start by looking at, well, first of all, does it match your handout? Yours is a sine function. Thank you. So it shouldn't be capitalized, but you get the idea, right? Okay. First of all, let's look at a and d. Let's only look at a and d because we want to find out where to put those dotted lines so we know what to sketch. D is -4 and a is -7. So first of all, dealing with a being -7, that just means there's been a vertical reflection, and we'll tackle that when we need to. The most significant aspect of this is that the amplitude is 7. The most significant aspect of this is that the vertical displacement is -4. And much like the phase shift, we can say the displacement is negative with trig functions. We don't have to say it's 7 units down. But if the vertical displacement is -7, whoops, -4 rather, If the vertical displacement is -4, I might have said -7 a minute ago, I apologize. If the vertical displacement is -4, then that middle of the graph, which is usually here, will no longer be there. It's going to be here. The top of the graph and the bottom of the graph have to be 7 above and 7 below because the amplitude is 7. So the top of the graph is going to be 7 above, which puts it here. The bottom of the graph will be 7 below, which puts it here. How many of you feel as though knowing what A and D were, you could have written the range without looking at the graph? You'd go down to -4 and then you'd add 7 to get the max, take away 7 to get the min. If you can't do that, then this diagram is really helpful. Even if you're not asked to graph it, why don't you just draw those lines so you can see the spacing? Okay, what is the value of B? What is the value of B? Well, it's 2, isn't it? Do you not have a 2 in front of the x? So that's B. That's 2. What does that tell us? It tells us the period is pi. Because the period, I will remind you over here, and then I'll erase it because it's just going to get in the way, will be 2 pi over the absolute value of B. And B is 2, so 2 pi over 2 is pi. Whatever we draw from the start point has to go through one complete cycle in pi, not 2 pi. And what is C, also known or formally known? It's the parameter formerly known as H. What is the value of C? Noah? It's not pi. It's pi over 2 because you have to factor the B out. Right? That's that thing going back to Unit 1 that we cannot forget to do. So when I write this in the proper format, I'm going to have -7 sine. I take the 2 out, and then I have x minus pi over 2 n bracket minus 4. So the phase shift is pi over 2. So C has a value of pi over 2, which means the phase shift is positive pi over 2. And what I'm going to tell you here is you always worry about C last. C is the troublemaker here, okay? So let's put this all together. It is a sine graph which starts at the center, at the middle. That's a fact. So we put a dot right here. And a sine function will start in the middle whether A is positive or negative. Because if A is positive, it starts in the middle going up. If A is negative, it will start in the middle going down because of the vertical reflection. So what we know so far is this. And that's what I've drawn is just a note for us. We have to draw something that starts there and goes down. Okay? And it's going to repeat every pi. So it's actually, and I'm not sure you want to draw anything yet, it's actually going to start here, and it's going to go down, up, up, down. Right? In between 0 and pi, it's got to do that full cycle. Except that's no longer the start point. Because of the pi over 2 phase shift, the start point now is here. It's been shifted pi over 2 radians to the right, so we're going to take that start point and move it pi over 2 radians to the right. Then we can draw it, and everything else is the same. If I start here and end pi radians later and go through the full cycle, I will have completed the accurate drawing of the graph. So I need to take this distance, this vertical line here is telling us where things start, and this is telling us where things end. I need to break that into 4 pieces. I know that it's going to be easy to break it into half which means that it will be starting here, getting back to this point, and then back to this point at the end. And again, it's going to go down, up, down. It has to go down to a point halfway in between those 2 points, and it has to go up to a point halfway between these 2 points. So that's the series of points that we have to do our best to draw the smooth curve through. It is going to go down, up, down. And if you like, you can repeat it. If you had to repeat it, you could start counting squares and putting a dot over here 6 units away, and a dot in the middle, and doing the same thing. Down, up, down. It would look like this. And you could do this all day long to your heart's delight. Okay? Any questions with that one? All right. A graph is shown. I'm pretty sure this graph matches your notes, but again, I've changed things. You'll notice that I jumped to example 4 because we just don't have time for as many examples as I used to do. So, does this graph match yours? Okay. What we have to do is find the equation of this function if it's a sine function where a is positive. And that means, everybody, that you need to determine the values of a, b, c, and d. And I'm going to give everybody a minute here to look at this graph and determine the value of a and the value of d. The numbers are so simple as to be almost laughable, right? -2 to 4. It's not a big deal. I mean, in my mind, I don't actually draw this, but in my mind, I ask myself where the top and the bottom of the graph are, and that will tell me that there's a total of 6 between the min and the max, so the middle is here. Now I know the value of d is 1. D is always, the vertical displacement is always the middle of the graph measured vertically. So d is 1, and I can see that the amplitude is 3, so a is 3. You know, could you have determined the amplitude is, well, I'm going to show you the mathematical ways that your textbook would teach you how to find a and d, or the amplitude and the vertical displacement. They would say for the vertical displacement, you take the max, you add the min, and you divide by 2. Can you verify that that's going to work here? That if you take the maximum value of y plus the minimum value of y and you divide that result by 2, you're going to get d? Okay. And then what your textbook will say is that the amplitude, we'll worry about the parameter a in a minute, is what you get if you take the maximum minus the minimum divided by 2. You get 3. Those of you that are memory people and you want something to glom onto in your brain, that's fine. But my experience is if that's how I taught everybody to do it and I didn't show you the visual of it, people are going to mix these things up. You can see how close they are to each other, right? Anyway, if you do require some kind of memory thing, that's what you could do. So we know a and d. A is 3. D is 1. We can figure out what b is. B will be 2 pi over the period. We can just look at the graph and figure out what the period is, and then we can figure out what b is equal to. Let's see. I'm going to use this as a start point in my cycle. It goes up, up, down, down, and it does so in this distance. This is the period. Would you agree? So we have to read what that is. Now, how do we do that? Well, I would start by looking at the fact that pi is 6 squares. What that means is 1 square is pi over 6. 1 square is pi over 6. This is pi over 6 to here, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6 is pi. Well, that means that this distance here is 4 pi over 6, which is 2 pi over 3. Okay. So we determine the period. Why are we doing that? So that we can figure out the value of the parameter b. I take 2 pi divided by the period. I can multiply top and bottom of this by 3. What I end up with is on the bottom, the 3's cancel. I'm left with 2 pi times 3 over 2 pi. Well, the 2 pi's cancel. K is 3. Or, sorry, b is 3. How many of you, I'm just curious, how many of you figured that b was 3 because the period is 2 pi over 3? So b must be 3. So sometimes it works out that way that you can just visually see it. So now, how do we find c? This is the tricky part, okay? This is the difficult part of this lesson. What we are going to do is leave c to the end, and we are going to sketch what this function would look like when a is 3, b is 3, and d is 1, but there is no c. Okay? So this is a sine function that's going to start in the middle going up, and it's going to repeat every pi radians. Are you with me on that? Okay. And the vertical displacement and the value of a have told us that these are the grid lines. So sine is going to start here going up. Correct? Does that take into account a and d? Yes, because those are the guidelines. Does it take into account the period, or b? Yes, because it's going to tell us we have to start here and end at pi. Does our graph, whose equation we want to find, does our graph that we want to find the equation of start at that red point? It doesn't. That means we have to shift that red point to a place where the graph matches up. And that means I can take this and shift it this way. I can shift it pi over 6 to the right to make it work. And that's how you can find c. There's another way that we'll get to in a bit. So c is positive pi over 6. Could you have said, all right, so I'm going to assume c is 0 and it lands here. Could you have said, I'm going to shift it this way to make it match? Sure. I would have a negative phase shift of 1, 2, 3 pi over 6 to the left, which is pi over 2. 3 pi over 6 is pi over 2. So I could have said, or negative pi over 2. I'm going somewhere with this, okay? Could you have said, and I have no idea why you would want to, I'm going to shift it that. Sure. There are an infinite number of shifts, but usually what we're after is a smaller shift, a minimum shift. So what are the equations, or what is the equation for this? It would be y equals 3 sine 3 times x minus c, which is pi over 6, close brackets on the argument, plus 1. The nice thing about b is it's almost done. We know that it's still going to be a parameter of 3 for a. It's going to be cosine this time. It's still a parameter of 3 for b. It's going to be x minus c, n bracket, plus 1. All of these parameters, a, b, and d, do not change. The period is still 2 pi over 3, so we need b to be 3. The amplitude is still 3, we need a to be 3. The vertical displacement is still 1, so we need d to be 1. What's different now is that instead of having this talking about sine, we're talking about this with cosine. Cosine starts at the top going down. Does the graph whose equation we're asked to find happen to start at that red dot going down? No. But if we translate this pi over 3 that way, or pi over 3 this way, we would get the right equation. And that means that C can be either positive pi over 3 or negative pi over 3. It doesn't matter. And because my brain couldn't cope with the degree radian mode thing, and we've wasted a few minutes here, we're not going to graph them. But if you put your calculator in radian mode and you graph this, or you graph this, or you graph this, or the one with negative pi over 2 in for C, they are all going to be correct. If you want to graph it in degree mode, then you have to put not pi over 6 but 30 degrees, not pi over 3 but 60 degrees. Are we good? Okay. Now comes the most difficult type of question. We want the equation of this using a sine function. Okay. It should be child's play to find A and D. I'll give you a minute to figure out what A and D are equal to. What makes this more complicated is there's not a grid to look at, and the numbers are bigger. I want to say 19 for A. What I'm doing is looking at how far it is from the negative 7, which is a y coordinate, up to the positive 31. This total distance is 38 units, if I added correctly, and I'm pretty sure I did. So if I divide 38 by 2, that gives me the amplitude of 19, which means I can use A equals 19. What is D? Well, if the amplitude is 19, then D, which is the middle of this graph, needs to be halfway between the maximum and the minimum. So if I take the maximum of 31 and subtract 19, and then, just for kicks, take the minimum of negative 7 and add 19, I have to meet in the middle if I've done the amplitude right. And 31 minus 19, I believe, is 12. And negative 7 plus 19 is 12. So D is 12. B is the next simplest thing to find. It's not difficult, but it requires a little more work. B can be found by taking 2 pi divided by the period. So that will give us 2 pi divided by, well, what? What's the period? The x-coordinate of that first maximum is negative 6, and the x-coordinate of the next minimum is 24. So that's a total distance of 30 units from the negative 6 to the 24. Are you with me on that it's 30? That means the period is 60, because the period is twice that distance. From this point to this point, you're going down, down. That's only half a period. You still have to go up, up. So the period is 60, which tells us that B has a value of pi over 30. Okay. And so far, our equation is this. We're after a sine equation this time. Yeah. 19 sine pi over 30 x, we're going to have a minus c in here, plus d, which is 12. We in agreement? Okay. Here's the problem. You cannot find c in this question in the way in which we found c in this question. 1, it's not in radians. 2, we don't have a grid. If you are capable, here's the problem, if you were capable of imagining where the graph of this is without the c, and then figuring out in your head how to shift it to get this graph, good luck trying to explain that on a written response. So instead what we do is we say this is a missing parameter. And this will work for the previous question too. How do you identify the value of a missing parameter? You always use a known point. And if you use any of the points that I'm going to highlight, you can find C. If you knew any other points, coordinates, you will never be able to find C this way. So it doesn't matter which one you use. I'm going to use negative 6, 31. So we're going to put 31 in for y. We're going to put in negative 6. I want to double check that. Yep. For x. And what we want to do, everybody, is rearrange this for that. We're going to actually solve this equation for C. I'm going to have to subtract 12 from both sides, correct? And then I'm going to have to divide both sides by 19. Do that for me. Figure out what we're going to get when we rearrange this for sine of pi over 30 times negative 6 minus c, n bracket, n bracket. What do we get when we do that? And you should get, I believe, 1. And here is what will always happen. This is a question you will see on your exam. You'll probably see it on the diploma exam. This is what will always happen when you get to this stage. The trigonometric ratio will always be equal to 1, negative 1, or 0. And if it's equal to anything else, you've done something wrong, or you've picked a point that's impossible to work with. Okay? So this is, on the unit circle, the y coordinate. Which means this is the y coordinate. The sine of this mess, the sine of that whole thing, is equal to 1. If I gave you, this is tricky, if I gave you sine of theta equals 1, everybody who knows what they're doing would say theta is pi over 2. Right? Well, that means that pi over 30 times negative 6 minus c is equal to pi over 2. Because the sine of that is equal to 1, the angle itself must be pi over 2. And now you can solve that. The pi's cancel. If I multiply both sides by 30, I get negative 6 minus c equals 15, because 30 divided by 2 is 15. If I add c to this side and subtract 15, I get negative 21. That's your phase shift. Just to take this to a different level, if you take negative 21 here, and you take negative 6 minus negative 21, you get 15. 15 over 30 is 1 over 2. You get pi over 2, and sine of pi over 2 is 1. So C is negative 21, which means our equation is going to be y is equal to sine pi over 30 times x minus negative 21 plus, was it 12? 12. The weird thing about this missing parameter in this equation is had you chosen a different point, you would have gotten sine of something equals maybe 0. And if you got that, then this angle would have to be 0 because sine of 0 gives you 0. You may get negative 1 depending on the point you pick, in which case this is going to be 3 pi over 2, where sine is negative 1. And the result is you can get different phase shifts, but they're all correct.